Okay, so we're going to talk about our next family of molecules. We're going to talk about lipids now. We've done proteins, we've done carbs, so now it's time for lipids. Okay, so lipids have a lot of different purposes. They're a storage molecule, and that's one that a purpose we're going to talk about a lot. They're cell membrane components, so we're going to talk about phospholipids, but then we're also going to talk about the membrane and the lipid bilayer. So it's really interesting the way the molecules align to give it the function it needs. We're going to talk about eicosanoids. They're like baby hormones. They send signals, but they're made where they're needed and they don't stay around like hormones do. They're precursors to steroid hormones, vitamin D, bile acids, things like that we'll be talking about also. So we have different types of lipids. We might have precursor lipids, might have simple ones, complex ones. We might have cholesterol. We might have derived lipids, and we'll talk about all of those. Okay, so our precursor lipids are made up of carbon, hydrogen, and a carboxylic acid. So what we're going to have is we're going to have a chain of carbons. We'll have our chain of carbons, and we'll have the carboxylic acid on the end. That makes it a fatty acid. So when the fatty acid is not attached to anything, we call it a free fatty acid. We'll also use the term unesterified. And it's kind of a weird term because what we're saying is it's not attached to anything in an ester bond. We're describing the bond we're not using anyway. So a little weird, but we do it. And I want you comfortable with that term. So our fatty acids that we're going to make contain an even number of carbons. They might be saturated, meaning no double bonds in there. Saturated with as much hydrogen as we can possibly put on there. Or they could be unsaturated, meaning we have double bonds somewhere in the chain. When we're saying, and this comes up always after you've had time to think about it, when we're saying double bonds or no double bonds, that one doesn't count. We just mean in the chain itself. So be a little careful there. Usually when we're doing it, it's, yeah, okay. Then you do actually say, oh, hang on here, got a double bond. That one doesn't count. So most of our fatty acids are naturally occurring in the cis configuration. The rest of the world likes the trans configuration. Fatty acids are the exception, and of course, you get asked about the exception more than the norm, typically. So we have some physical properties that make things a little bit different. Lipids are not soluble in water. And you'll notice we're going to make a big deal about that fact when we're talking about digestion and absorption. They're soluble in nonpolar solvents. We'll use that. The melting point is kind of a thing. Saturated fatty acids longer than 12 carbons are solid at room temperature. Unsaturated fats with 2 or more double bonds are liquid at 0 degrees Celsius, or freezing. Okay, let's talk about our naming. In the Chem Review, we talked about prefixes. So we had meth as 1 carbon, eth as 2, bute, pro, pent, hex, and so on. So the first syllable of a fatty acid is the number of carbons. First syllable is number of carbons. Fatty acids are always going to end in oic acid. If it's saturated, as in based on an alkane, it'll have the number of carbons and an oic acid. So the an for alkane. If it's based on an alkene, as in it's unsaturated, it's going to be a number of carbons and oic acid. And of course, no space there and same size font. When we say it verbally, it's a little difficult to pick up on. Octanoic acid, octanoic acid. So it's usually written that you see the difference. but no double bond saturated, at least one double bond unsaturated. Okay, so our prefixes using the scientific name, and then there's some common names. You don't have to know all of those. I'm going to give you a set of notes that are the most commonly asked ones that you'll need to know. And of course, Dr. Krabbe's going to talk about a lot of these in nutrition. So you'll get very, very familiar and very, very comfortable with them. Okay, we can have mono unsaturated, one double bond. So a couple that you're going to get very familiar with are palmitoleic acid and oleic acid. Oleic acid is pretty famous as olive oil. When we have a polyunsaturated fatty acid, we're going to add another piece to the word. So what we're going to add is we're going to have the usual. First part of the word is the number of carbons. Then we're going to have our oleic acid. And of course, these two are one word. But we're going to add another piece in here, which is going to be the same prefixes with the number of double bonds. So let's say we're talking about fish oil. We have icosa. That's 20 carbons. It has 5 double bonds, so we're going to have icosa penta. So icosa pent, actually penta, and then N-oic acid, so En. So this is number of double bonds. This is the alkene unsaturated part. And then oic acid. Of course, one word, even though I have it split up so you can see the parts. So icosa pentan oic acid is our fish oil, 20 carbons, 5 double bonds, and unsaturated oic acid for fatty acid. Okay, and a few examples. And here we have the number of carbons is 18 or 20, and the number of double bonds. Okay, we have a couple of different ways of describing our fatty acids and our fatty acid structure. So we're going to talk about both of them separately. We're going to talk first about omega fatty acids. So I'm just going to make up a fatty acid so we have something to work with, and I'll put some carbons in it. And we can put our hydrogens on there if you want. And let's talk about numbering carbons. So we're numbering carbons, properly numbering carbons. We're going to start with the carboxyl carbon. It's carbon 1. Next one's carbon 2. We add another carbon, we be 3, 4, 5, all the way along to whatever we have. Don't forget our carbon 2s are alpha carbon, carbon 3s are beta, and so on. We're not going to use that now, but we're going to come back and use that later. When we're determining what omega number the fatty acid has, is it an omega 1, an omega 2, whatever, we're not going to count from the carboxyl end, we're going to count from the methyl end. So remember, 3 hydrogens on here make this a methyl group. Therefore, it's ugly therefore, oops, oh, I didn't mean to do that. Therefore, we call this the methyl end. I'm really killing this. This is what happens when you do too many videos in one day. So this is our methyl end. So I'm going to count from the methyl end, and the first carbon I come to that touches a double bond makes it an omega-3, omega-6, or omega whatever fatty acid. So I'm going to start at the methyl end. Here's my first carbon. Here's my second carbon. Here's my third carbon. It's touching a double bond. So that makes it an omega-3 fatty acid. Let's do another one quick. So we said I'm going to count from the methyl end. First carbon to touch a double bond makes it whatever number omega it is. First carbon, second carbon, third, fourth, fifth, sixth. That's the one. So that makes it an omega-6 fatty acid. So I'm putting first, second, third, fourth on these very, very much on purpose. I don't want to put 1, 2, 3, 4, 5 because they're not carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So I'm doing that very much on purpose. Maybe, depending on what fatty acid it is, if I started counting at this end, 2, 3, 4, whatever, maybe, carbon 6 would be the one the double bond's on. I don't know. Doesn't matter. I want to count from this end, the non-carboxyl end, the methyl end, and that will tell me whether it's an omega-3, 6, or whatever. A couple other things with this. When we get into elongating fatty acids and adding more double bonds, there's some rules. When we elongate fatty acids, or when we do pretty much anything to fatty acids, we're going to do it 2 carbons at a time. And that just comes back to the molecule we're starting with when we make the changes we're going to make. So everything's 2 carbons at a time. The other rule we have is that double bonds can be no more than or no less than 3 carbons apart. That gets really important for knowing what's going on. So they can't be any more than, they can't be any less than 3 carbons apart. So that will matter a little bit later. But here's the thing with omega fatty acids. Whatever omega number it is, no matter what you do to it, it's going to stay that omega number. So what that means is I can't do anything between that double bond and the end of the molecule. Because if I change the number of double bonds, or if I added carbons, it wouldn't be an omega-3 anymore. I can't do anything here between that double bond and the end of the molecule. Because if I did anything there, added carbons or added double bonds, it's not going to be an omega-6 anymore. So that means anything I do has to be in here. Anything I do has to be in here. Anything I do is going to be adding double bonds and elongating the molecule. With those rules in mind, double bonds have to be no more than, no less than 3 carbons apart. I do my adding 2 carbons at a time. The other thing we can do with the omega classification is we can say how many double bonds are in it. So we'll come to that. Okay, let's talk about delta. With the delta classification, we're going to start at the other end. So I'm just going to make up a fatty acid. I didn't prepare this. Thinking right now I should have. Okay, totally making it up, so I might have messed it up too. But it'll work, you'll get the point. Okay, so this is my fatty acid. Like I said, totally making it up. But let's number our carbons. So we're going to do true numbering now. We're going to start at the carboxyl end. I've got carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are my true carbon numbers. So here's how my delta classification is going to work. My first number is going to be the number of carbons. 12. I was thinking 18, but I ran out of room. So it's going to be 12 carbons. Second number is going to be the number of double bonds. So I got 1, I have 2. Next is going to be my delta. Delta is going to name the carbons that the double bonds are on. So I've got 1 on carbon 6, and I've got 1 on carbon 9. So it's a delta 6, 9. So with that information, I could take that and I could draw this molecule. We went the other way with it, but I could draw this molecule. I would draw 12 carbons. I know I have 2 double bonds that I need to put in there, and I know what carbons they go on. So that's my delta classification. So number of carbons, number of double bonds, and then the location of those double bonds. Omega, start counting at the methyl end, the non-carboxyl end. First carbon to touch a double bond, that makes it omega, whatever that carbon is. Then we can say how many double bonds we have, knowing they're no more than, no less than 3 carbons apart. So some delta and some omega classifications of some common fatty acids that you will be seeing. And you're going to be making polyunsaturated fatty acids. You'll be doing more of that in nutrition class. But what you're going to do most often is take an essential fatty acid, make it a non-essential by adding double bonds and or adding carbons. Our enzymes are often desaturases, meaning we're adding double bonds in there. We're desaturating the molecule. Of course, we can never make an essential fatty acid. We can only make non-essentials. And again, let me remind you, I'm still using the term essential, non-essential, even though you're going to hear in nutrition dispensable and indispensable. We made the decision that for the time being, we want you comfortable with both terminologies. We don't know which one you're going to get, so we want you okay with whichever one you might get. Like we said, whatever the omega classification is of a fatty acid, it's not going to stay. Or it's not going to change. So an omega-6, no matter what you do to it, has to still be an omega-6. An omega-3 stays an omega-3, and so on. Okay, so you can go through, and we won't do this, you'll do it later in nutrition class and everything, but we can go through and look at the delta numbers and look at what we're doing. We're going to desaturate at carbon 6, so now we have 3 double bonds added 1 at carbon 6. Going to desat, we went from 18 to 20. Sorry, the PowerPoint's a little skewed. We added 2 carbons. That's going to move our double bonds over. Added another double bond, and so on. So you can see your progression. We won't do this one, but same idea. You can see your progression through. I'm not changing my omega number, but I am adding double bonds. So I'm changing the delta and adding carbons. So I'm changing, again, the delta because my double bonds, they're not really moving, but I'm adding 2 carbons. So it's changing the number that double bond is on, even though it's still on the same carbon. And overall, I'm changing the number of carbons. Okay, we're going to talk a little bit about pathology. And some of this we're going to do in a couple of shorts. We're going to do some biochem shorts, just like YouTube and all that. So some of the pathologies, the lipid peroxidation we'll do in a short. LDL cholesterol we'll talk about a little bit now. So we can have cis and trans fatty acids, like we said, structurally. We want cis. We want a cis fatty acid, a naturally occurring fatty acid. We're designed to process those. So we'll talk about it a little bit more later, but if we have trans fatty acids, they're going to be metabolized very similarly to a saturated fatty acid. We can raise our LDL cholesterol, our bad cholesterol, lower our HDL cholesterol, our good cholesterol. We may end up getting a fatty acid deficiency as a result. The foods that are high in trans fats are exactly what you would expect: margarine, French fries, things like that. And don't forget, with food labeling, you might be looking at a food that says it has 0 grams of trans fat, but as long as it's below half a gram per serving, you can say 0. So watch out for that, especially with serving sizes. I can make the serving size really, really small to get me in the window of less trans fat or 0 grams trans fat. Okay, some essential fatty acid deficiency diseases. They're particularly related to omega-6 and omega-3 fatty acids. Being deficient in omega-6 fatty acids can result in scaly skin, eczema, things like that. Not as common. An omega-3 fatty acid deficiency is more common and more damaging. Can be trouble concentrating, can go as far as heart disease, eye diseases, things like that, because DHA is found in the retina, cerebral cortex, testes, heart, places like that. Okay, we're going to stop here. Lipid peroxidation, we're going to do in a separate video as a short.